The H5N1 controversy and the dual-use dilemma. In 2011, two manuscripts, under review by the high-profile journals Nature and Science, raised concerns about the dual-use potential of the research. The manuscripts illustrated the successful synthesis of a more deadly variant of highly pathogenic avian influenza, H5N1. Previously, the virus could only be transmitted through direct contact with infected birds. The new variant, developed by two research teams, one in the US and the other in the Netherlands, was capable of airborne transmission between mammals. This development was significant. H5N1 has shown a case fatality rate of 60% in humans. In other words, for every 10 people infected, 6 have died. By comparison, the virus responsible for the 1918 influenza pandemic, or Spanish flu, had a case fatality rate of only 2.5%. The Spanish flu was transmissible between humans and resulted in one of the worst catastrophes in human history, causing 50 million deaths. So, why produce a more deadly variant of H5N1? Why enable it to be airborne? From the perspective of the participating researchers, the research was necessary to raise awareness about the pandemic potential of the virus, to prepare for a worst-case scenario. From their perspective, it was better to know what is possible than to wait and see if H5N1, through natural mutations, could spark a global catastrophe. For others, the so-called gain-of-function experiments were irresponsible and should not have been conducted in the first place. What if the synthetic virus accidentally escaped the lab? At the very least, now that the experiments were conducted, many argued that the research findings, or at least the research protocols, should not be published. What if criminals or terrorists repeated the published procedures and gained access to the virus? It could, according to some, offer criminals and terrorists a blueprint on how to set off a flu pandemic. After reviewing the proposed publications, the U.S. National Science Advisory Board for Biosecurity, or NSABB, agreed with this perspective. It advised that the journals Nature and Science should publish redacted versions of both manuscripts. While the basic conclusions of both studies should be published, the relevant experimental methods and details which might permit the experiments to be replicated should not. For critics of the H5N1 gain-of-function experiments, this was a sound decision. For others, the NSABB's proposal set a dangerous precedent, as censoring science could undermine long-held norms of scientific freedom and openness. They argued that for science to function, transparency and the capacity to review and challenge research positions based on open publication was essential. Choosing the best option, whether to censor the manuscripts or to publish them in full, emerged as a source of global controversy. In this climate, the World Health Organization assembled a group of experts to assess the pros and cons of both positions. Following their review, they supported calls for open publication. In their view, the benefit of raising awareness about H5N1's pandemic potential, enabling further research, and the development of appropriate countermeasures outweighed the risks of accidental or intentional misuse. Ultimately, the NSABB agreed with the conclusions of the WHO and reversed their earlier call for censorship. In 2012, the controversial papers were published in full. The controversy surrounding the H5N1 gain-of-function experiments serves as an important reminder of the inherent dual-use nature of life science knowledge. It also reminds us of the need for societal debate on how such research should be communicated, or even if the research should be pursued in the first place. The dual-use dilemma underscores that there are both benefits and risks enabled by advances in the life sciences and biotechnology. Even though this particular controversy has come to a conclusion, there will certainly be more examples of dual-use research in the coming years. Indeed, in the words of the NSABB, while full publication was justified in this instance, research findings will likely emerge in the very near future that should not be widely disseminated because of a high risk of misuse. In this light, what should be done to address the dual-use concerns in the future? There's no one answer to this question, but several actions could help. First, scientists and research institutions should consider if some research projects are worth the risk to begin with. Once dual-use research has been undertaken, the possibility of undoing the experiment is no longer possible. Moreover, as the H5N1 case study demonstrates, proposals to restrict the publication of research findings in scientific protocols after the research has been undertaken will likely continue to draw strong resistance from stakeholders who argue against censorship in science. Second, journal editors should insist that papers submitted for publication include sufficient background on why the research was undertaken, what are the benefits of the research, and what biosafety and biosecurity steps were followed to mitigate the possibility of accidents and deliberate misuse. For example, insisting on the inclusion of information stating that research was reviewed by a biosafety committee could help diminish fears. Third, given that life science research and biotechnology are rapidly evolving, leading to new safety and security challenges, it's important to actively engage the public and inform them about the risks and benefits of dual-use research. It's important to invite their views at an early stage, including with regard to the steps that could be taken to mitigate misuse. This will not only help instill trust, but also create a sense of shared responsibility.